Alright guys, in this box we got a new server rack battery from Calpha. You know the drill. Alright, we got some cables here. So there's our main positive and negative terminal cables, and it has these quick disconnects on them. We have our communications cable. Looks like they supplied us with some crimp-on terminals. I'm guessing you would cut this wire and crimp one of these on if you're just trying to connect one battery. Our manual. Oh, we got a quality control packing slip here. Alright, and here's the battery. Unfortunately, I did get a little bit of shipping damage. The handle right here is a little bent, but it really just looks fairly superficial. We'll open it up and check the inside and see. Alright, so this is the Calpha BR51 100. So it's a 48 volt battery, 100 amp hour. So let's go ahead and open this guy up. Here we go. Okay, everything looks super tidy in here, and I don't see any damage on the internals from the shipping. Looks like two 7-gauge wires for the negative. I'm thinking a 4-gauge for the positive. The cells have aluminum bus bars, laser welded. All the BMS wires are labeled and tidied up very clean. They're routed very clean in these channels right here. Looks like we got one metal strap that goes across the top to hold the cells down. The back of the cells are underneath this lip here, and everything has this insulated material on it, so it's not going to cause any shorts. And then the front of the cells also has this, they're under this lip right here. So yeah, they're definitely in there, very solid. The bus bars do have this relief hump in them, so that's very good. I do see a temperature sensor right here on this cell, on the positive terminal, and then one more on the negative terminals. Okay, so let's turn this guy on for the first time. Alright, we got a run light flashing here. There we go. Shows state of charge, I guess, is at like 75%. And let's check and see what the voltage is. We got 52.7 volts. Okay, so I went ahead and tore the front panel off. That way I can start to try to fix this bent up metal, which shouldn't be too hard at all. But now we get to take a good look at the BMS and the front panel guts. Just a massive BMS there. Here's our main negative. It looks like a copper with a nickel plated bus bar there. And then here's our main positive. Kind of about the same style bus bar. And that connects directly into the bottom of the breaker. And the BMS says Vest Woods, VESTWOODS. It's a VW10CLCH01V03. The only thing that I have seen so far that I didn't quite like is this is the main positive right here, and the positive wire goes down this channel. And then the main negative is here, and it overlaps the top of that positive. The wire is literally laying on top of the nut right here for the positive. And I'll show you guys what I'm talking about when I'm putting this back together. Alright guys, I think I got it pretty well banged out and flushed up. And just using the magic of some wood blocks and hammer. So let's put it back together. All mounted back up. It's a million times better than what it was. Alright, so let's move on. And I want to show you guys what I was talking about with that negative wire. So I haven't connected it yet, but see how it's laying in this channel. And here it is right here. Got a piece of tape on it so I don't short anything out while I'm showing you. But there's the positive wire that runs down there. And as you can see, this negative wire just sits right on top of that nut. and there's an indentation right there. And you can see it lays down, and then it has to bend over that nut. See that? So that nut is really poking up into this negative wire. All right, so what I've done is I taped a couple of slices of fiberboard to the bottom of the negative cable. Now that's not the best solution, but that's the best one I can come up with for right now. All right, so let's turn it on and see if we're still functional. All right, I see our run light on. All right, we're back to like 75% state of charge. And we're showing 52.7 volts. And before we button this thing up, let's try to get a scan on the QR codes of the cells and see what they are. Oh, look at that. We've got EVE cells. So lithium iron phosphate. The model is LF100L. 100 amp hours, 320 watt hours. The production date was 10/6/2023. I didn't really expect to see EVE cells in this unit, but that is a very high quality cell. All right, so in order for us to hook this up to something that I own that we can use to charge and discharge, I'm having to convert these cables over to these type of terminals, and it did come with these as I showed you on the unboxing. So I've already cut one of these quick connect terminals off and added this standard M8 style terminal to the positive, and now I'm just going to crimp one onto the negative. I've got it already ready to go. I just got to put it in my hydraulic crimper here. I'll throw the link in the description to these. These are super cheap and super handy. You'll get a super solid crimp. All right, so I've got the battery hooked up to the EG4 6000 XP, and let's flip the switch here. All right, so it looks like we're online now. Let's flip the breaker here. Let's see if, okay, yep, we're on. Sorry, there's a huge glare. There we go. So now let's turn the solar on. Okay, our normal light is on. Yeah, it looks like we're charging with 400 watts. Let's see what we're putting in. Yeah, 5 amps. Let's try to run a load. It's 75% charged, so we should be able to run a load fairly fine. All right, so we got the old dryer plugged in to the inverter here. Let's turn the AC output on. So it's running it. It's probably exceeding what it's supposed to be. Yeah, okay. It actually shut the dryer off, I believe. Yeah, because we're only supposed to pull 100 amps. And it says 125 for 1 second. So let's try to run the dryer again. All right, so we're already pulling 50 amps. And that's because the dryer is actually broken. It actually runs and burns power without it being on. That's why I had to replace it. But if I turn it on, and yeah, I see like we're pulling over 100. We're pulling 121. So I'm going to turn it off because it'll make this trip again. And so we're back to putting in 5 amps from solar. So I'm just going to let it sit there and fully charge. And then I would like to do a capacity test on it. All right, guys, so the battery's all fully charged. We're going to do a capacity test. We're going to use this electronic load tester here. So let's go ahead and turn the battery on. All right, so the battery's on. We've got voltage here on our load tester. We can see 53.4 volts. I've got it set to discharge at 2.7 amps. So that should get us around 150 watts, I think. So let's go ahead and start the test. Yeah, there we go. We're discharging at 143.9 watts. And we'll just let that go, and I'll come back when it's complete. All right, so it's the next day. I think it's been about 12 hours or so. Let's get a little progress report on our discharge capacity test. Looks like we're at 37.8 amp hours and about 2,000 watt hours. All right, so I'll just let it keep on going. It's going to be a while. So we're at 100 amp hours, 5,235.6 watt hours. Still going, but at this point it's past its full capacity. We'll just let it keep on going and see where it ends up. All right, and the test has completed, and we have 103 amp hours, 5,370.4 watt hours. All right, guys, so I think that's going to be the end of the video. I might eventually test the communications on this battery. From my understanding, this uses the PACE protocol. But thanks for watching. Leave your comments, and I'll catch you on the next one.